Ya, bagi yang video recorded tu datang. Okey.
Okey. Assalamualaikum dan selamat sejahtera. Saya dan kumpulan saya ingin membentangkan tentang topik trigonometry. Lecturer kami ialah Puan Nureliza binti Mat. Team member saya adalah Muhammad Amiruddin Salwani, J. Arwin dan Aiman Syafri. Our table of content for today is introduction, application of trigonometry in selected areas, mathematics solution and the conclusion. First of all, triangle is a trigonometry is all about triangles. Trigonometry helps us find angles and distance and is used a lot in science, as example engineering, video games and more. The triangle of most interest is the right angle triangle. The right angle is shown by the little box in the corner. As you can see here, the picture of the triangle. Triangle showing opposite, adjacent and hypotenuse. Another angle is often labeled theta, and the three sides are then called adjacent, opposite and hypotenuse. Adjacent is always next to the angle theta. Opposite is always opposite of the theta, and the longer side of a triangle is always the hypotenuse. The main function in trigonometry are sine, cosine and tangent. As we all know, we call it soka and toa. They are simply one side of a right angle triangle divided by another. For any angle theta, for example, sine theta equal opposite over hypotenuse, cos theta equal adjacent over hypotenuse, tan theta equal opposite over adjacent. To find any each of these, we can use this method. For an example, the question is, what is the sine of 35? So we must find the answer of sine of 35. If we use sine theta, we must substitute the opposite over hypotenuse. So sin 35 equal opposite over hypotenuse 2.8 over 4.9. If we put in calculator, we will get 0.5714, and we must round off to 2 decimal place, and we get 0.57. Example of modern construction involving the application of trigonometry. The example of construction in nowadays is bridge, buildings and pyramids.
Hello, my name is J. Arvin, and let's talk about trigonometry in architecture. First, a little bit about architecture. Architects design buildings and other structures. In addition to considering the way these buildings are structures look, they also make sure they are functional and safe. Architects not only draw the plans for the buildings, but they have to make sure the building follows safety codes, and they also have to plan the budget for the building. Trigonometry used to solve architectural problems. Trigonometry is used in architecture to ensure that buildings are built safely. For example, architects have to calculate exact angles of intersection for components of their structure to ensure stability and safety. Examples of trigonometric use in architecture, including arcs, domes, support beams, and suspension bridges. This is another example of how architects use trigonometry, where there is a ladder, and to find the angle or the angle of the ladder so that it will be stable. To see how far up something, the trigonometry ratio you could use would be sine. Apart from that, trigonometry can be used to find the length of a wall. You can solve this by using tangent cos. Trigonometry used in navigation. Trigonometry is used to set directions such as the north, south, or east, west. It tells you what direction to take the compass to get in a straight direction. It is used in navigation in order to pinpoint a location. It is also used to find the distance of the shore from a point of the sea. It is also used to see the horizon.
Hi, saya Sarwani. Application of trigonometry. A building is 50 feet high at a distance away from the building. An observer notices that the angle of elevation to the top of the building is 41 degrees. To the nearest foot, how far is the observer from the base of the building? So, tan is 41 bagi equal 50 bagi x. X tu pindah ke kiri. Jadi x tan equal 50. X 50 bagi tan 41. So jawapan dia 58. Observers is 48 feet from the base of the building. How tall is the Eiffel Tower? At a distance of 118 meters away from the tower. An observer notices that the angle of elevation to the top of the building is 61 theta. Tan 61 equal S bagi 180 darjah. So 180 darjah pindah ke kiri jadi 180 darjah tan 61 equal X. Jadi jawapan dia X 324.7 meter.
Solve the right triangle round decimal answer to the nearest 10. Approximate BC by using a tangent ratio. Okay, firstly, approximate BC by using a tangent ratio. Kita ambil tan 42 darjah. Kita letakkan di belah kiri sama dengan BC bahagi 70. Dan 70 yang belah bawah tu kita gerakkan ke kiri, dia akan jadi 70 tan 42 sama dengan BC. After that, 70 tan 42 kita tekan kalkulator, kita akan dapat 63.0 sama dengan BC. And then approximate AB by using a cosine ratio. Okay, first kali kita ambil cos 42 sama dengan 70 bahagi AB. And then kita gerakkan AB ke belah kiri, dia akan jadi AB cos 42 degree sama dengan 70. AB sama dengan 70 bahagi cos 42. Apabila kita gerakkan cos 42 degree ke belah kanan, kita akan tekan kalkulator 70 bahagi cos 42 degree sama dengan 94.2 AB. Answer. The side length are 70 feet, about 63.0 feet, and about 94.2 feet.
Okay, this is another example of trigonometry used in architecture. A radio station tower was built in two sections. From a point of 87 feet from the base of the tower, the angle of elevation of the top of the first section is 25 degree, which is the below, and the angle of elevation of the top of the second section is 40 degree. The nearest foot to the nearest foot, what is the height of the top section of the tower? Okay. First of all, we should draw a right angle triangle, and so that we have a clear picture. So the total height of the tower is y, and the top section of the tower is x, and the below section of the tower is y, o, and it's given the angle is 25 degrees and 40 degrees, and the adjacent length is 87 feet. First of all, we should find the total height, which is y, by using tan theta equals to opposite over adjacent. Here, to find y, we should use tan 40 degrees equals to y over 87, and by using the calculator, and 87 tan 40 equals to y, and y, you will get y 73 feet. Then to find the second section height, the below section height, you should use tangent 25 degree equals to opposite over 87. Using calculator, 87 tangent 25 equals to O, and you will get O 40.57 feet. To find X, we should minus the total height of the building minus the first section, which is O. So X equals to Y minus O, which is X equals to 73 minus 40.57 feet equals to 32.43 feet. Thank you.
You want to put a fence around your property which is in the shape of a right triangle. You know the hypotenuse is 90 feet and angle is 20 degree. How much fencing do you need to purchase? Okay. First of all, we need to put a 90 feet, then 90 cos 20 degree sama dengan, dan kita bagikan, kita akan dapat jawapan dia X sama dengan 60 cos 20, dan kita akan tekan kalkulator, dapat jawapan dia 56.4 feet. And then untuk dapatkan jawapan Y dia, kita masukkan 60 sin 20 sama dengan 60 sama dengan Y sama dengan 60 sin 20, dan tekan kalkulator, kita akan dapat 20.5 feet. And then kita akan tambahkan semua sekali 60.0, 56.4, 20.5, tambahkan semua sekali akan jadi 136.9 feet.
Okay, last but not least, we go to the conclusion. We realize that trigonometry can be used in many areas such as astronomy and architecture. They can aid in calculating many things. They can also be used in cars, decks, and bench. Without really climbing a tree, you can find the height easily with trigonometry. They can be so widely used in real-life application and is very useful for most architects and astronomers. We can conclude that without trigonometry, life would be much more difficult. Without going through the troubles, you can easily find something, so we think that it was a good invention by Archimedes. And thanks to this, many architects need not go through the trouble to calculate things. So it really helps in real life application and not only in our tests and exams. And that's all our book today. Thank you.